All right, a couple of things that we're going to talk about in terms of that linear relationship. So we talked about linear versus nonlinear, positive or negative, and is it a very weak to a very strong relationship? Well, we're going to get some more specifics on that here right away. So we have this special thing called the correlation coefficient. Okay, thankfully denoted little r, lowercase r, much easier to write that than continually writing out correlation coefficient. It is a number that tells us two things, okay? The first thing it tells us is the strength of the linear relationship, which means how closely to a straight line the data falls, which we talked about that, okay? Super strong would mean the data is almost perfectly straight in a line. And then it also tells us whether the association is positive. So in other words, the value of r itself is positive. That means it's a positive slope. The data is going uphill, or negative. So that would mean the value of r is negative and your data would be going downhill, okay? A negative slope. Now, there are some properties of that linear correlation coefficient, and they are as follows. First of all, the value of r is always from -1 to +1, okay? It will never be outside of that range of numbers. If r is 1, okay, that means there is a perfect positive correlation. In other words, your data happens to lie on a perfectly straight uphill, and it doesn't matter how uphill. I mean, that doesn't relate to the slope necessarily at all. Like, it's just saying it's positive. Okay, so like those data points, for example, would fall well, close to a perfectly straight line. So would these. This would be a perfectly positive uphill linear relationship. Okay, so it's not about the slope. It just means all those points line up as like little soldiers. And r equals -1 is the exact same thing, but in the negative direction. Okay, so you would have these points that line up in a perfectly straight line that goes downhill. And again, it's not about how steep the slope is, it's just how they line up. Okay, right smack dab in the middle, okay, of perfectly negative and perfectly positive would be r is 0, and that means that there isn't a linear relationship, okay? I kind of call that like your snowstorm or your blizzard. There's no rhyme or reason. It's just kind of these dots just all over everywhere, and there doesn't seem to be any pattern at all whatsoever, okay? All right, so next thing we're going to do is find the linear correlation coefficient for the old faithful data. So there's a few things you're going to have to do. So you're going to need to pause the video at various times to do this. The first thing I need everybody to do is I need you to turn a certain thing on in your calculator, because if you don't, you aren't going to see any of the values that you need to see. Okay, so the first thing I need you to do, and you only have to do this one time, okay? This is a one-time deal. You never ever have to do this again. So you need to press the second button on your calculator, and then you need to press 0, which is catalog, okay? So second, 0. And then I need you to hold the down arrow. Just hold it for a while. It's going to start scrolling, okay? All those commands that you're seeing are in alphabetical order. I need you to find the one that says diagnostic on. Okay, so scroll down, get all the way to diagnostic on. Once you find diagnostic on, I want you to press enter. Okay, that will put the words diagnostic on your calculator screen, and then I need you to hit enter again. And on your screen, it should say diagnostic on, done. Okay, if that's happened, you're good. Okay, move on. If it doesn't say diagnostic on, done, then try it again. Okay, and again, you never ever need to do that again. Once that's been done, you're done. All right, so what I do need you to do right now is pause the video. Well, get the directions, then pause the video. I need you to enter the data from the duration and the interval the Old Faithful data, I need you to enter that data into L1 and into L2. Okay, I want you to put the duration, the first column, in L1, and I want you to put the interval in L2. And you know how to do that, so pause the video, go do it. Okay, once your data is in there, then what we're going to do is run a linear regression. Okay, so to do that, what you're going to do is you're going to press the Stat button. Then you're going to arrow over to calculate, okay? And then you're going to arrow down to ln reg ax plus b, okay? For me, it's number 4. Now, if you look a little further, there's probably another one that says ln reg a plus bx. It's fine if you use that one, but the a and the like things are going to look a little backwards. So just use the same one, and then we're all consistent, especially since this is a video, okay? So once you do your ln reg ax plus b, it's going to ask you where your x list is. So your x list in this case will be L1, okay? Where did you put the independent variable? Your y list will be L2. The frequency list, just leave blank. And then when it says store reg EQ, just ignore that. Okay, so all you want is X list L1, Y list L2, arrow down to calculate, and it's going to spit out some numbers. Okay, now in this particular question, notice that we were asked to find the linear correlation coefficient. That is the R value. Okay, so what does the R value say? Well, hopefully it says that R is 0.845. Okay, now what does that tell us? And again, this is the important part, okay? Like I can get a small child to push all those buttons. They won't necessarily know what they mean though. So what does the R value tell us? Well, this goes back to the box there at the top of the page, okay? Since R is fairly close to 1, okay? It is pretty close to 1 for sure. We can say the duration of eruptions and the interval between eruptions have a fairly strong positive linear relationship. Okay. If you don't want to use the words fairly close, if you want to say like, I don't think it's very close. I mean, we're close, but I don't think we're like super close. This isn't like a 0.97 or something. But again, fairly close. So you're again ranging from really a 0 to 1. Okay, 0 is no relationship, 1 is perfectly linear. And remember, a negative only tells you that it's a downhill or negative relationship. Okay, so really when it comes to strength, 0, not strong at all. Okay, no linear. 1, perfectly linear. The sign just tells you, is our data going generally uphill or generally downhill? All right, the last thing we're going to get here in this one is the percent of the response variable y that is explained by the explanatory variable. And response, okay, so this would be, again, our dependent and explanatory independent, and those words get switched around a lot. So sorry, but that's just the way it is. It is determined by what is called the coefficient of determination. Okay, and that value is R squared. It's also right there on your calculator, but it literally is the value of R squared. Okay, so if you clear out your calculator or whatever too soon and you wrote down R, you can get to R squared. So using 4 decimal places here, R squared should be 0.7138. And then what does that mean? Okay, so as a percentage, this would mean that 71.38% of the variation in, now our dependent or our response variable, so that is the length of intervals between eruptions, again, our dependent variable, can be explained by the duration of the eruption. Okay, so there are other things that come into play. Okay, that's basically what it's saying, but 71.38% of the variation, the changes in the length of intervals between eruptions, is explained by, not caused by, but explained by how long the eruption happens to last. Keep that screen up on your calculator, by the way, that where you did your linear regression. As you head into the next video, we'll still be using it.